Dear students, in this video we are going to discuss about the how to write dimension formula and what is the dimension formula and which are the dimensionless quantities, what is mean by dimensionless quantity, and some previous questions will be given in the last of this video. So this is the first part of dimensional analysis concept. You have to observe it. Simply in this video we are going to discuss about the how to write the dimension formulas very for simple physical quantities. Let's go for that. What is a dimensional formula and what is a dimension? If any physical quantity can be expressed with the help of base quantities and their powers and that should be kept in a square bracket, it is called as a dimensional formula. A dimension formula is nothing but a physical quantity can be expressed in terms of base quantities with their powers and those are kept in between the square brackets. It is called dimensional formula. So before going to discuss about the dimension formula and dimensions, so we have some fundamental quantities are there. 7 fundamental quantities. Mass, that should be having dimension formula, that should be expressed like this, capital M. Clear? Similarly for length, L, and time, that should be having dimension formula, T. And thermodynamic temperature, that should be expressed in terms of K or theta. And electric current, that should be expressed as A or I. And luminous intensity, CD. And amount of substance, that should be expressed in terms of MOL. Clear? Now to understand simply, I will give one example here. Volume. What is mean by volume dimension formula? Simply we have formula LBH is there. For length also we can express in terms of capital L, and for breadth also like this, and height also L. Then bases are equal, we have to add the exponents 1 plus 1 plus 1. Then what is L cube? L cube is the dimension formula of volume. Here 3 is called dimension of L. That means the power what we are writing of a quantity, that should be called as dimension. Clear? Here 3 is the dimension of here L in that volume dimension formula. So dear students, what we know, density is equals to what formula? Mass per volume. Here what is mass? Dimension formula capital M. And what is the dimension formula of volume? Just only we discussed L cube or L to the power of 3. Then what we write here? ML inverse 3. Clear? So here M is mass kg and L is length kg meter inverse 3 or kg per meter cube. It is the unit of density. In the same manner we can write the dimension formulas for different physical quantities. Look here. Here velocity dimension formula is what? Here velocity formula is what? Displacement by time. Displacement for time. Then what, right? L by T, that is equals to what? LT inverse 1. Here LT inverse 1 is the dimension formula of velocity, and dimension of L is what? 1. Dimension of T is what? -1. And units are now here for L meter, for time second inverse, now here meter for second. And in the same manner acceleration we can write. What is acceleration? Velocity by time, change in velocity by time. Then what right here? LT inverse 1 is the velocity dimension formula and time is T. Then what it is? LT inverse 2. And similarly here we can write force. Force is equals to what? F is equals to MA. Now M is what? Mass. LT inverse T is the acceleration dimension formula. Then what we write here? Dimension formula of force M L T inverse 2. So here dimension of M is what? 1. L is what? 1. To the power of minus 2. T is what? Minus 2. And now here, according to this formula, units are kg meter second inverse 2. And that should be also called as Newton. What we call? Newton. And now pressure. Pressure, force per area. Force per area. What is the pressure force dimension formula? M L T inverse 2 and A L square. Then what you get here? M L L to the power of minus 2 and T to the power of minus 2. Here M L to the power of 1 minus 2 and T inverse 2. Then what right here? M L inverse 1 T inverse 2. Clear? This is the dimension ball of pressure. So here units are what? Kg meter inverse second inverse 2. And according to this one, force per area, Newton per meter square. Newton per meter square. In this way we can write the dimension formula for different physical quantities. Similarly, we can write dimension formula for different quantities. For example, here angle. Angle is equals to formula is arc for radius. Arc for radius. So here both are belongs to same category of dimension of length. Then it is a dimensionless quantity. Dimensionless quantity. And here strain. Strain also dimensionless quantity. Change in dimension. Change in dimension for original dimension. Original dimension. So it is also dimensionless quantity. Dimensionless quantity. And now, but units are there here. For angle, units are radians. And strain is the dimensionless quantity and unitless quantity. And now here stress. Stress is nothing but again force per area. It is like equals to the dimensional formula of pressure. Already we discussed. And here F is equals to G M1 M2 by R square. In that formula, what is G? Universal gravitation constant. We can write G is equals to F into R square by M1 M2. Here what is F? Force. M L T inverse 2 and R is what? Distance L square by mass M square. Then what right here? M to the power of minus 2 L cube and T inverse 2. Then what is right here? M inverse 1 L cube T inverse 2. This is the dimension formula of universal gravitational constant. And now here E is equals to H nu. E is equals to H nu. And here H is the Planck's constant. Then H is equals to what we write? We can write E by nu. What is again E? E is the energy. Its dimension formula is ml square T inverse 2. And frequency is what? 1 by T. That is what? T inverse 1. This is the ml square T inverse 2. So substitute here ml square T inverse 2 by nu. Nu means what? T inverse 1. Then what write? Ml square T inverse 2 and T. Then what write here? ml square T inverse 1. Clear? And we can write angular momentum. L is equals to mvr. Again same here. M is capital M, velocity LT inverse 1 and R is L. Then what is here? M L square T inverse 1. Here you can observe Planck's constant and angular momentum both are having same dimensional formula. And now here, so according to this one we got that formula unit kg meter square second inverse 1. Here are the same thing. Okay. So here what is the unit for force? Newton. R is the distance meter square for kg square. Newton meter square for kg square. And torque tau is equals to R cross F. What is F? M L T inverse 2. And what is R? L. Then what right here? M L square T inverse 2. So dear students, when we have idea about the formula, you can easily write the dimension formulas. Okay. Now let's see one example here. The dimensions of epsilon naught E square. Dimensions of epsilon naught E square, where epsilon naught is the permittivity of free space and E naught is the electric field. So this was given in 2000 JEE mains. Some options are given: ML T inverse 1, ML square T inverse 2, ML T inverse 2 and ML square T inverse 1. Clear? So here dear students, of epsilon naught E square, it is the expression for energy density. It is the expression for energy density. It means that energy for volume. Energy for volume. So obviously we know about the dimension formula of energy, that is what? M L square T inverse 2 by volume L cube. Then what you write here? M L square L to the power of minus 3 T inverse 2. So M to L inverse 1 T inverse 2. M L inverse 1 T inverse 2. So look, compare here. M L inverse 1 T inverse 2. So no option is matched. M L inverse 1 T inverse 2. That's why the question given options are wrong options. This is the right one. Let's see another problem. It was given in 2013 JEE main. Let epsilon naught denotes the dimension formula of the permittivity of vacuum. If F is equals to if M is equals to mass, L is length, T time, and A is the electric current, then some options are given. We have to find out it. So epsilon naught is what? Permittivity. So according to the Coulomb's law, we have F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Clear? From that what write? Epsilon naught is equals to 1 by 4 pi of Q1 Q2 by what it is here? R square. So that is what epsilon naught is equals to here Q square by R square into F. R square into F. So this is the formula we are going to use. Here Q square, what is Q? Q is the charge. I is equals to Q by T. From that what write? Q is equals to ID we can write. Therefore Q is equals to A T. So Q is equals to what? Here A T. And R is what? Distance L. And what is F? M L T inverse to force. Then substitute here. Epsilon naught is equals to Q square A T whole square by R square L square into F M L square T M L T inverse 2 M L T inverse 2. Therefore epsilon naught is equals to what? A square T square by L square M L T inverse 2. That means what? A square T square and L square L cube, and it is minus 3. Clear? And here M is there and D inverse 2 is there. Therefore what right here? M inverse 1 and T square. M inverse 1 T square. Then what right here? Epsilon naught is equals to what we write? Epsilon naught is equals to, first you can write mass. M inverse 1 and L inverse 3 T square T square T square T to the power of 4 to the power of 4 to the power of 4 and A square and to the power of 2. So therefore dimension formula of permittivity is what? M inverse 1 L inverse 3 T to the power of 4 A square. So B option is the correct one. See the next question. It was given in the NEET 2005. The ratio of dimensions of Planck's constant and that of moment of inertia is the dimension of. The ratio of dimensions of Planck's constant and moment of inertia. Moment of inertia is the dimensions of. Options are given. First option time, frequency, angular momentum, velocity. So here what you have to find out? Ratio of Planck's constant and moment of inertia is equals to what? Which dimension formula? So already we discussed E is equals to h nu. What is h? Planck's constant. That is equals to what? E by nu. E by nu. Clear? Then what it is? M L square T inverse 2 by T inverse. So why? Because frequency is equals to 1 by T time. Then what is here? M L square T inverse to T. That is what? M L square T inverse 1. Clear? And what is I? Moment of inertia. I is equals to M R square formula. That is what? M L square. What is M L square? Therefore what is here? H by I. H is what? ml square T inverse 1 by L square. And ml square. So here obviously ml square going to be cancelled. That is what? T inverse 1. So T inverse 1 is what? Dimension formula of what it is? Frequency. Dimension formula of frequency. That's why here among the options, second option is the right one. See the next question. If E and G respectively denotes energy and gravitation constant, then E by G has dimensions of. 4 options are given, and it was given in the 2021 NEET exam. So what was given? E is equals to what? Energy. E is equals to what? Energy. So its dimension formula what we know? M L square T inverse 2. And what is capital G? Gravitational constant, universal gravitational constant. So that is what? Simply we know that M inverse 1, L cube and T inverse 2. This is the dimension formula. Now what to write here? E by Z. M L square T inverse 2 by M inverse 1 L cube T inverse 2. We can write. So therefore M to the power of 1, and it is M to the power of 1. L square, L to the power of minus 3, T to the power of minus 2, and T to the power of T square. Then what are here? M square, L to the power of minus 1, and T to the power of 0. So M square, L minus 1, T to the power of 0. Therefore second option is the correct one. M square, L to the power of minus 1, T to the power of 0. Okay, thank you for watching.